We talk a lot about how classrooms are going to have to shift quite a bit in order to meet the new next generation science standards. So in this episode of Extreme Makeover NGSS Edition, we look at the classic activity of flower parts. My son came home from school yesterday and said that they started a new life science unit in his science lab. And the very first thing that they did in their science lab was the teacher passed out to them a worksheet that looked a lot like this. And my son could go ahead and he could recite all sorts of fancy words for different parts of a flower as they began their lessons. But I began to think of myself, is this the best way to start an NGSS lesson? So let's take a look. One of the first things I thought about this lesson is that it introduces a whole bunch of vocabulary before it introduces what I call a need to know. Now there's a lot of discussion of something called front-loading of vocabulary, where you introduce essential words that people can't understand the concepts unless they understand those words. But I would like to propose to you that the words that are right here are not essential to understanding a flower, and therefore they should not be the types of words that are front-loaded. We front-load words that are really impediments to understanding, where you can't talk about things without those words. And within science, we prefer to embark upon a different approach to vocabulary. And let me show you how that looks in NGSS. NGSS really shifts when and how we introduce vocabulary. So we want less of this side here, where we might begin by saying, all right, class, there are 6 main parts to a flower: petals, the sepal, the anther. And what we've done in there is we've introduced a label, described that label, and then we might have the students go and look at a diagram or look at a flower itself and verify that label in the natural world. NGSS turns this on its head, where we want to do something different. We want to begin by experiencing some sort of phenomenon, noticing something that's happening in the world. Then within that, we're going to identify a pattern in the world. And then if we need to, we will go ahead and label that pattern. So vocabulary becomes labels to key ideas that we want to discuss. This idea of vocabulary becomes important when we begin with the end in mind. Where is NGSS asking our students to go? Well, in this particular case, our teacher is trying to target 2-LS2-2. This performance expectations where students are developing a simple model that mimics the function of an animal in dispersing seeds, or in this case, in pollinating plants. And that's obviously where the teacher really wanted to introduce the parts of a flower, because you can't mimic the functioning of an animal in pollinating plants without understanding how pollination works. And you can't understand that without understanding the parts of a flower. So it's clear there's some important disciplinary core ideas that the teacher is going after, that plants have different parts, and those parts help them survive and grow, and reproduce in this case. That's part of LS1.A, but also within LS2.A, that you can see this 2 here corresponds to this 2 right here, because this performance expectation is really trying to build upon the LS1.A and go into the idea of interdependent relationships in ecosystems where plants depend on animals for pollination. So that's where we're going. Nowhere in here does it require students to understand the vocabulary of this. They're going to be developing a model. They might need that language as they go along to. So let's think about how we can do Extreme Makeover NGSS Edition and turn that flower parts activity into something that begins with the phenomenon. And before we get to a phenomenon, we kind of need to make sure that our students are all on the same page, that we're drawing on what they already know, building on their existing experience. And so I'm going to ask students to picture a bee in their head. Look at it buzzing around, watch it for a little bit in your head, in your imagination, and then draw that bee in your science notebook. Now, most likely, your students in 2nd grade are coming up with a bee that looks a lot like this one here. Probably has a smiley face even. And this is great, because we're going to ask them to take this and this level of understanding a little bit further and push their understanding and think about what do they really know about bees. So let's take a look at the next slide. Next, I'm going to have my students address this question in pairs. If you could reach out and touch the bee, what would it feel like? Is it scaly like a lizard, or furry like a squirrel, slimy like a worm, or smooth like a ladybug? Now, I want you to think about how you would answer this, but I also want you to think about how a second grader might answer this and what information they're drawing on in their head, what associations they are making. Now that we've gotten our students to really commit to some ideas about bees in their heads, we show them this picture. And this, well, this is not what I expected a bee to look like, quite honestly. It has all these hairs on it. And just to make sure that you're convinced this is indeed a bee, you can see its orange and black stripes on the back there. But what are all these hairs? And if you look a little bit closely, you see it kind of seems dirty, like it's not just got hairs, but those hairs seem to have yellow stuff on them. And now we have an interesting mystery. Why is the bee all hairy, and what are all those yellow things? Whenever we see something crazy and unexpected in science, it's always a good idea to ask, did I do something wrong, or is that some strange, one-of-a-kind fluke? Well, in order to answer that question, we need to get a little bit more data. And we have, in this particular case, 2 more pictures, a little bit more data, and we can look for a pattern. Do all these bees have that hairiness to them? Well, this one certainly does, and this one does as well as this one having a lot more of that yellowish, orangish stuff stuck to those hairs. So what is going on? We now have a mystery. So next, I went on YouTube and tried to find some really good examples of bees up close as they visit flowers so we can watch them. And here are some screenshots from a video clip that you can get to at this URL, and you can also watch it on the next screen. Clearly the bee is going inside that flower for something and is getting pollen on it. So what is in there? Well, we're going to figure that out. And so to do that, we need to collect a whole bunch of flowers to look at so we can look for patterns. And so I'm going to send my students on a schoolyard flower hunt. Now, hopefully you've got at least a few different types of flowering plants in your schoolyard somewhere, either flowering trees, from potted plants, from the landscaping, from your garden, but you may not. So you might need to stop off at your neighbor's front yard and grab a few flowers on your way into school in order to provide students a variety of flowers to look at and to take apart. The challenge that we give them is to carefully dissect that flower so that they can figure out where the pollen is coming from, which part of the flower, and what it looks like inside. The next stage in this dissection process is to tape all those parts down onto a piece of paper into their science notebook, and then draw a picture showing how they fit back together. And you can see that the student has drawn some petals over here. This part of the flower looks like it fits right in here. They found the pollen. In fact, there's beautiful yellow spots right here. They figured out that those go in this spot. And then there's some other little tiny things that go right in the middle of things. So this is the type of diagram that we're hoping our students will be able to construct on their own. Do our students' pictures look like the one in the worksheet that we began with? Not really. These are much simpler. But do they need to? I would argue no. And I would also like you to notice the complete lack of vocabulary in here. This is very intentional. We've only introduced the vocabulary that we needed. In particular, I would probably introduce 3 terms at this point: the stem and the petal, because these 2 words are tier 2 vocabulary, meaning that they're useful in everyday life, but they're a little bit specialized to the world of flowers. So I think that these are useful words to introduce to our students, and so I'm going to make sure I have those labels. And then I've introduced a new term. It's not necessarily the specific scientific term, but it is a scientific term. It's using everyday language. It's the pollen source. And that refers to this little piece right here. It's not the scientific term, but I think that this particular term is actually going to be more useful for our students as they're designing their models of pollination, because they have a pollen source. And you can begin to think about the opposite of a source is a place to put your pollen in the end, a pollen receiver. And so we can start using that terminology, and that's going to really help them get the idea of what's going on with the pollen and the movement of that material. So in this particular case, my use of a non-standard vocabulary might actually help students understand things a lot better. So now our students just need a little bit more information about that pollination process, and they need to figure out exactly what the bee is doing and how it helps move the pollen from one part of the plant to another. But they have that foundation, so maybe they'll do a little bit of a reading exercise, or maybe watch a short video clip and some animations, so that they can have a good sense of what it is that's going on during pollination, such that they can begin the engineering design process to design that model that mimics how pollination works in plants. And you can use the engineering design process like this one shown here from the Engineering is Elementary kit to really get your students into thinking about how they can mimic pollination processes.